I'm Seth Page from DataRPM. We automate predictive maintenance. I was going to start with a data scientist joke, but I just was advised to skip over it, so my apologies. The key challenge that happens right now is that data science today simply isn't ready for the industrial IoT, right? We've got zettabytes of information, 11 going to 44, where 40% of that is actually machine-generated data. So you'd have manual models today that take samples of data from samples of sensors, from samples of assets, right? We build generalized models and then extrapolate and force them on an asset population, and then wonder why we get poor results, right? The type of results we get are only 20% of the asset failures today are predictable and common, right? The other 80% are just random and individual to whatever asset they happen to happen. And that just can't be tolerated. So if you want to get at that other 80%, you have to build individual predictive models for every single asset of the industrial IoT. Some of the key challenges is that because that every asset is unique, it needs a digital twin, right? You need to be able to update that digital twin in real time as new data comes in. And that's because the operational and the environmental and even the manufacturing conditions are constantly changing for every single asset out there, right? And the key thing is those things drive the health of the asset. So if you're looking at 20%, success rate, that's just not going to work. You need to look at all of the data that's being produced, and then you need to be able to build individualized models to actually make predictions. Right? Sample data sets, manual models simply don't work for industrial IoT. And you also have other problems like lots of unlabeled data and the need to use unsupervised learning. What we do is our solution is using meta learning on top of machine learning, right? And that's teaching machines to automate machine learning on their own, right? We're the first ones to take it and do it at the enterprise level. We use meta learning on top of machine learning and data science automation, and there is a lot of economic value buried in there, particularly around cognitive predictive maintenance, right? That's where most of the money and most of the problems are for IoT is there in industrial IoT. How do you teach machines to do meta learning? Well, it's somewhat of an algorithmic survival of the fittest, right? You're running many experiments in ML, typically hundreds, thousands, in some cases tens of thousands in parallel for every single individual asset. Then you're extracting the metadata and selecting certain features and attributes and hyperparameters. Then you're actually training an ensemble of models, not just a single model, for each and every asset. From there, we actually apply it to predict the best models and hyperparameters, and then we can deploy it, right? So typically you're looking now at a machine-generated model that's fully automated with some human validation on top of that that's individual for all those specific assets. The results are pretty obvious. We just launched Q1 this year. We've already saved our clients over $200 million in identifiable cost savings. On average, there's an 80% increase in prediction power right out of the gate. Some of our clients are now pushing the 300% mark. We can deploy in days and weeks, not months and years. And average cost savings for our clients is 30 to 40% now. And some of them are just happy if they get 2 or 3%, right? You get these large billion-dollar BUs. Some of our clients are up there on both the private side up top and the public side down below, including some 3-letter government agencies. In use cases, right? You get some really interesting things in here. The average industrial washing machine has 75 sensors. That's more sensors than today's connected cars on the road, right? So this is being able to select and identify the failures for individual parts weeks or even a month ahead of time and send the right truck with the right part and the right technician at the right time so they don't break their SLAs. When you start to look at large generators, right, these go from tens to hundreds of millions of dollars. Those SLAs get very expensive very fast, and they start at 30 sensors and can go up into the hundreds. Connected cars coming out next year for our clients, over 120 sensors for their new models, for the 2017 models. And there's all sorts of interesting predictions you can do there, both in the cloud and then also on vehicle by pushing those models to the edge. And of course, locomotives, right? 2,400 sensors on the average locomotive in the US today. So you could bring down fuel costs, increase efficiencies, and bring down noise by using all of that data that's being captured today. You get in, some of our customers have a lot of roboticized assembly lines. Tons of data in there, it variables, sensor weight, and then things like electronics, TVs, set-top boxes, right? You got hardware, firmware, software, network configurations, error codes, maintenance records. We can predict when they're going to fail, why they fail, and how to fix them before that happens. Other things we're doing is in medical equipment, for yields, in heavy machinery, for transmissions and engines that now have more sensors on them, reducing rework for assembly lines in automotive, inventory stocking for semiconductor replacement parts, right, for the manufacturing equipment, and that gets into optimizing inventory and having more spares and doing just-in-time inventory. You know when something's going to break weeks in advance. And then being able to do better yields, obviously. And then finally, things like pumps, right? You would never think that a pump is connected today, but when you get to some of these larger industries, and they'll have over a dozen sensors on some of their higher end pumps. So we're looking at everything. There's a lot of fat to cut in some of these older businesses, and we're helping them do it. Key differentiators here is we have meta learning, right? We're doing cognitive automation. We're enabling the digital twin to happen. We're a fully open box solution, so you can see the code as it's being built. As a data scientist, you can look at it in R, Python, Scala, whatever you feel like. And then you can also look at it as a natural language search query or at the GUI level if you're more of an analyst or a business user. So you can democratize that for more people. We also have, we're highly distributed computing. We work in the cloud, we work on-premise and in hybrid solutions. So we're very flexible there. And of course, we're API driven, right? You can use our microservices, you can use our micro apps, but the reality is most of our clients consume the APIs in the software platform they're already using. Partnership with the Accelerator has been fantastic. They give us access to the right people at the right time. We've already migrated to Azure. We've integrated HD Insight for our new release coming out in 2 weeks. We're bringing the Azure ML library on right after that, around the January timeframe. We're working on some clients together. And I think the key thing for us is that we're filling the gap for cognitive predictive maintenance for Azure in the industrial IoT. If you'd like to talk to me, feel free to email. I'll be back there afterwards, and I want to thank you very much for your time.